So we'll recap a little bit of yesterday, and then we'll take it today. I want to get to graphing parabolas today, because that's the homework sheet that we have, the front side. And then I want to get to, hopefully, in the last class we didn't, so I'm probably going to put a video out there of going in reverse, finding the equations of it. Okay? So, if we're graphing, the first thing that we have to look at is we have to look at which way it's open. We did this yesterday. What were the two things that we looked at? Okay, that was the second thing. And? Which variable is squared? Okay, so we've got four options, right? Up, down, left, right. Okay, so if our parabola opens up, which variable is squared? X is squared, and the non-squared coefficient is positive. Okay, if it opens right, y is squared and positive non-squared coefficient. Down, x is squared, negative on the non-squared. Left, y is squared, negative on the non-squared. Okay? So that's all here. Okay? So if x is squared, it's going to open up or down. If it's positive, if that non-squared variable is positive, or that coefficient is positive, it's up. Otherwise, it's down. If y is squared, it's going to be left and right. And if that 4p number is positive, it's going to be right. Otherwise, it's going to be left. Okay? Then, we went to finding the vertex. And we said that the vertex of our parabola is at the point h, comma, k. And we said if it's inside a set of parentheses, we got to think opposite. Okay? There are the two standard forms. The left one here is for up and down parabolas, x, because x is squared. The right one here is for left and right parabolas, because y is squared. Okay? And so we think oppositely inside a set of parentheses, h, comma, k is our vertex. Okay? And we found them. Okay? So then now today we'll hit step 3. Step 3 says we have to find p. And the reason that we have to find p is because it is the distance from the vertex to the focus and from the vertex to the directrix. So by finding p, after we found the vertex, we can find the coordinates of the focus and the equation of the directrix. Okay? So, here is that 4p number. So 4p is equal to negative 12. So what's p? Negative 3.
Just 3.
But because it's a distance, we call it just 3, right? Okay? Right? So, let's back up 2 steps. First, which way does this parabola open? Y down. And the negative coefficient, right? So this one opens down. Where is the vertex of this parabola? What do you got? 3 comma negative 1. Do we agree with that? Okay. So now, let me just do a little sidebar action over here. Okay. So we got this. So we got our vertex over there. And this parabola is going to open down. Right? Okay. So that means that my focus is going to be down, because the focus is inside the parabola. So my focus is going to be p units down from the vertex. So my focus will have the coordinates 3, -4. Because that is 3 units down from my vertex. My directrix will be 1, 2, 3 units up from the vertex, which is going to be a horizontal line. So those are y equals lines. 3 up is going to be y equals 2. Agree. Questions? Okay. So just by finding this p-value right there, we can now find the focus and the directrix. If we would have gone in sequential order, we would have had that blacks and that blue stuff done already. Okay. Okay. So we're there. Getting closer to actually graphing it. Whoops. Okay. Now, this is new for you. Back in Algebra 1 and in Algebra 2, we taught you the 1-4-9 relationship when graphing parabolas. Left and right 1 from the vertex, you either go up or down 1a. Left and right 2, you go up or down 4a. Left and right 3, 9a. Left and right 6, 36a. And you squared however many you went left and right, multiplied it by a, and that's how you went up or down. Okay? So if a was a positive, or if a was a number bigger than 1, you got a really skinny parabola. If a was a fraction less than 1, you got a really wide parabola. Okay? Well, here now, we're going to look at this 4p number, okay? Because that's the number, so 4p is the coefficient of the non-squared variable. And that is going to determine, that's how wide our parabola is through the focus. Okay? So again, if I go back to there was my vertex, here was my focus. So because my parabola is 12 wide through the focus, I've got to go in equal direction, or equal distances each way. So I have to go 6 in each way. 12 divided by 2 is 6. So I'm going to count out here 6. 1, 2, 3. Oops, I missed, because 3 should be right there. 3, 4, 5, 6. So this, and then that point would be on my parabola. This would be a distance of 6. And then 1, 2, 3, 4, 5, 6. This would be a distance of 6. And that point is on my parabola, so that my parabola is 12 wide through the focus. Okay? And then we can draw it in. Okay? Because it sets our width. So let me draw it in. Okay? So that 4p is a nice number to have. because it gives you the distance to your focus from the vertex, distance to the directrix from the vertex, and it also tells you the width of your parabola through the focus. Okay? One last part is the axis of symmetry. Okay? So the axis of symmetry is the line through the focus and the vertex. It's also perpendicular to the directrix. Okay? Quick, easy way, if you follow those steps, to see what your axis of symmetry is you go back here and you look at your list. You look at these two. What's repeated in those two? The x value, and it's 3, right? In this case, it's 3. So my axis of symmetry is x equals 3, because it's the repeated one in those 2 points. Let's put all of that together now. Okay? So to recap, you have all of these written down, so you probably don't have to write them down again. I'm going to go through them a little quickly. Okay? So first off, we find our direction of opening, depending upon what variable is squared and the positivity of our non-squared variable. Okay? So if x is squared and 4p is positive, it's up. If y is squared and 4p is positive, it's right. If x is squared and it's negative, it's down. Y is squared and it's negative, it's left. Okay? That's our first thing. Second thing, whoa, jumped on me, is we find our vertex. We think oppositely inside parentheses, because that's going to be our starting point. And that's going to be where we start. Then we find P. We find P by taking 4P, the number in front of the non-squared variable, and we divide that by 4. That's important because P is the distance from the vertex to the focus and from the vertex to the directrix. Then, 4p is also the width of our parabola through the focus. So we set that width, draw in our parabola, and then lastly, we add in our axis of symmetry. Okay? Ready to put it to work? Let's do it. So, here's the first one. I gave you some graph paper today. You have plenty of graphs on there to graph the 3 that I want to get through in the next 20 minutes, which is more than enough time. Okay? So, first one is y squared equals 20x. My first question to you is, what direction does this parabola open? Why right? Y squared and the 4p coefficient is positive, so it's going to open to the right. Okay? Where is the vertex? At the origin? Because there's nothing being subtracted to the x, and there's nothing being subtracted to the y. So the vertex is at the origin. Now I go off on the side somewhere. I sidebar it, if you will. What is 4p equal to? 20. So if 4p is 20, what is p? 5. So that tells me that my focus is 5 units to the right, because it opens right. My focus is 5 units to the right of my vertex. So I would add 5 to the x, and I'd get that at 0.5, 0. That also tells me that my directrix is 5 units to the left of it. That's a vertical line. Vertical lines are x equals, and it's at -5. Agree? Okay. What is the width of my parabola through the focus? It's 20. So that means that I'm going to go 10 up and 10 down. That now allows me to draw in my parabola. There we go. And we'll fix it. We'll clean it up a little bit. There we go. Okay. And oh, come on now. Well, come on now. Too far out. Okay. And then the only thing that I have left is my axis of symmetry. What is my axis of symmetry? Y equals 0, because it's what's repeated in both of these 2 points. And there's my parabola. Okay. Now, I haven't written the test yet for this unit, but we will be having a test in this unit. Okay. In a graphing parabola problem, I would have the graph. I would give you the equation. Here's the graph, or have you give me the graph, and then I would probably ask you, what's the vertex? What's the focus? What's the directrix? And what's the axis of symmetry? For sure, I would ask you those 4 questions. Okay? The 4 different parts of that graph. Okay? So it helps to do it that every time. Okay? Yes, sir?
No, I'm not sure if you said this yesterday or not, but what exactly does the directrix do for us?
Remember that a parabola is all points equidistant from a point and a line. So it's the line that all those points are equidistant from. So if I take that point right there, okay, that point is, whoops, so that's a certain distance, and this distance right here are equal. And as I slide that point along the parabola, those two distances, this distance here is always going to be equal to that distance there. Okay? All right? Let's try one on our own. Which way does this one open? Up, x is squared, 4p is positive, so it opens up. I would concur. Where is the vertex? -2 comma -3. Do we agree? Thinking oppositely because they're both in a set of parentheses. -2, -3 is right there. So sidebar then, 4p is 16, so p is 4. So the distance to my focus from my vertex is 4 up. 2, 3, and 4. Oops, I should put an F there, not a dot. So my focus is at -2 comma +1. Do we agree with that? My directrix is 4 down. That's a horizontal line, so that's y equals -7. Yes? Width of my parabola through the focus. Michael, what's the width through the focus? 16, which means I go 8 in each direction, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I can draw it in. Make sure that it keeps curving at the end, so that, if we get out a little farther, it would almost be vertical. Okay, it doesn't just, once you get to those points, then it just doesn't go out straight. It keeps curving past those. Okay. One last thing is the axis of symmetry. What is the axis of symmetry? -2 is a number. X equals -2 is a line. And there we be. Okay? One more. Try that one. Direction of opening. What do we got? Left. Y is squared. 4p is negative. So that's a left opening. Vertex. What's the vertex? 2 comma -1. (4p) is -6, So P is going to be negative 3/2. Which is negative 1.5. So P is really 1.5. So my focus is 1.5 to the left. So that puts my focus at 1/2, comma, negative 1. My directrix is 1.5 to the right. Which is a vertical line, so that's x equals 3.5, which is 7/2. The width of my parabola is 6 through the focus, so I'm going to go up 3 and down 3, which allows me then to draw it in. And lastly, I have my axis of symmetry, which is a horizontal line, y equals negative 1. Okay? Did not get to going in reverse. There will be a quick 5-minute video on it today because it's just these steps. It's just utilizing them in a little different way, but it's the same math behind it. Okay? So watch that video at some point in time this weekend so that you know how to do the reverse action, finding the equations of parabolas given certain conditions.